All right, so this is part 2 of the 3.5 inverse trig function section. What we're going to talk about today are evaluating or finding exact values of these expressions when they don't represent angles that are actually on the standard unit circle. Okay, so here we go. We have tangent of sine inverse of 1/3. So again, we kind of know this isn't a unit circle problem really for us when you see something like this, where the sine value, that ratio here that's not one of our standard unit circle values. So we have a couple ways of going about this. If it's a sine or cosine value, then we can kind of set up a right triangle where we have an angle and we turn that into a right triangle. And the vertical component here is the y or the sine value. The horizontal component over here is the x value or the cosine value. And then the radius is 1. And it's just sort of assuming that this is intersecting with the unit circle somewhere, and we can kind of use this information. That's the way that I'm going to do this problem. The other way that we can do this is knowing that sine represents the opposite divided by the hypotenuse. And so we could label a slightly different triangle that way. It will be similar to this one, literally mathematically similar. It just will be scaled up version of that, or differently scaled version of this. So in this case, we have, again, our angle in here and the opposite side over here. The hypotenuse is here. So this would be 1 and 3. And we can kind of work from that way. A couple different ways of approaching this one. Oops, knocked down some pens. All right, so but both of these are valid. It kind of just depends on the problem, which one maybe makes more sense. All right, so we have sine inverse of 1/3. So we're looking for an angle somewhere that has a positive sine value. Remember, sine inverse always falls in these two quadrants between -pi/2 and pi/2. When we're doing a problem like this where it doesn't actually fall on the unit circle, at least in the standard places on our unit circle, we're just going to create a right triangle. So this has a positive sine ratio, so we know that means that we're going to be in quadrant 1. That's where we have positive sine ratios because the y-coordinate is positive. And we're just going to draw some angle in quadrant 1. I don't know what the angle measurement is, and I'm actually not even going to find it out. I don't need to know the exact angle measurement in order to solve this problem. So I know that on the unit circle, we always have a radius of 1. So we're just going to assume it's intersecting the unit circle here. We have a sine value. Our y value is 1/3. And we're missing the x value. We're missing the cosine value. And the reason we actually want to know that is because we're trying to find tangent of this angle. And tangent of any given angle is the y coordinate divided by the x coordinate. Well, we have the y, that's this one. We need to know the x. So we're going to have to find that. We're going to do a quick little Pythagorean theorem. It's going to be x squared plus 1/3 squared equals 1 squared. Simplifying this a little bit, we get x squared plus 1/9 equals 1. Subtract 1/9 from both sides. We're going to get x squared equals 8/9. And then we have to take the square root of both sides. So the square root of 8 is 2√2. And the square root of 9 is 3. So 2√2/3. So that is our x component here. And we do know it's positive because we're in quadrant 1. We're going positive to the right. And yeah, we should be able to kind of finish this problem off. Now we want to know the tangent of this angle, right? Again, we're not actually finding this angle measurement. We could throw this in a calculator and figure out what this angle equals as an approximation, but I don't actually care about that. Let me just do it here real quick. Shift sine inverse 1/3. We could see that in radians, it's like 0.34, approximately 0.34 radians. But I don't really care. I just want to know what the tangent of this angle is. And by setting up this right triangle, I can find the tangent of it. I can find the y over the x. Easy enough. It's going to equal 1/3 divided by 2√2/3. Instead of dividing these fractions, I'm going to multiply by the reciprocal. So this becomes 1/3 times 3/2 root 2. 3's end up canceling. 1/2 square root 2. And at this point, generally we would rationalize this. Multiply the top and the bottom by the square root of 2. In the numerator here, we end up with the square root of 2. Don't know why I was drawing it over there, square root of 2. And in the denominator, we have 2 times, this ends up being 2, which is 4. I'm going to rewrite that out. I feel like that's kind of messy. Square root of 2/4. So this is our tangent value of this angle. So that's what this is equal to, square root of 2/4. Again, it's kind of a weird problem. We're not actually finding out this angle at any point. Again, if we wanted to, I went ahead and threw that in the calculator here. You can see has a value. It's just we don't actually care what it is because all we're wanting to do is find the tangent of that angle. And by setting up the triangle, we can do that. All right, let's clear this. Go ahead and do another one. Cosecant of tangent inverse of -2. All righty. Well, starting here on the inside, tangent inverse, we do look same place as sine inverse. We look only from -π/2 to π/2. So we restrict ourselves to that range. We're going to have some angle here. It's negative, which remember, tangent is y/x. So in this quadrant, they're both positive. So tangent will be positive. But in this quadrant, we have a positive x and a negative y. So we're going to need to be down here in quadrant 4 this time, because this is a negative value, and that's where it's going to be negative. So I'm going to go ahead and sketch out an angle down there somewhere. Again, I don't really know what it looks like. I'm just making something up right now. We'll go like this. So here is our angle. This is it. Again, we don't care what it is. If we want to, we could just throw this in the calculator and figure out our angle. But again, let's just see what it is, but I don't actually care. It doesn't help me solve this problem as much. It's this -1.11 if we round that. So in radians. Again, we don't care what it is, but just as an approximation if you wanted to know. What I do care is that tangent of that angle is -2. That's a little bit tricky. I am going to do a little bit something different here. Last time I used the x and the y and the 1. I'm going to do this differently this time. I'm not going to do that. I'm not going to do x, y, and 1. I'm going to do old-fashioned opposite adjacent hypotenuse trigonometry here. So this is my opposite. This side over here would be my adjacent, and the hypotenuse is over here. Tangent, if we go back to SOHCAHTOA, this is something we may want to have to go back to, particularly for tangent. Tangent is opposite over adjacent. So -2 is equal to the opposite side divided by the adjacent side. Well, -2 can just be written as a fraction, -2/1. So for my problem, I'm going to think about my opposite side being -2. And that makes sense, right? We're going down 2, that's -2. And my adjacent side being 1. It also makes sense, we're going positive to the right one. We may need to make those adjustments in terms of which one is negative and which one is positive, because this negative could technically apply to either part of this, but it makes most sense here as the opposite is a vertical component because that is going down. Well, I want to know the cosecant of this angle. And cosecant is reciprocal sine. So sine is opposite over hypotenuse. So cosecant is going to be hypotenuse over opposite. So either way, I need to figure out this hypotenuse using my Pythagorean theorem. 1 squared plus -2 squared equals my hypotenuse squared. That's 1 plus 4 equals h squared. That's 5 equals h squared. So that means that h is actually equal to the square root of 5. The hypotenuse is actually equal to the square root of 5. And now we should be able to find the cosecant of this angle because we went ahead and drew the triangle that creates that angle. So the cosecant is hypotenuse over opposite, which is square root of 5 over -2. We're just going to go ahead and stick that negative over here. That would be our final answer. So again, these problems are not about finding the angle and then finding the trig value of that angle. They're about setting up a right triangle with the correct side lengths and then using that triangle to find the cosecant of the angle or the sine of the angle or the cosine, whatever the trig function of that particular angle that we want. And there we go. These are kind of challenging. There's some things going on here. All right. So here's the last one we're going to do here. This one's kind of abstracting this process, but I think I hope will make it make more sense rather than less. We'll see. So we're trying to show that this whole thing, that this whole thing here is equivalent to this. So I'm going to ignore this for a moment and just kind of figure out what's going on here. All right. So what's going on here? We have tangent inverse of v. V. I don't know what V is. It's just a variable, just a random variable, no numbers. Looks positive though, right? I mean, I suppose V could be negative, but I'm going to go ahead and make the assumption that V is positive. So I'm going to make the assumption that my angle is in quadrant 1. I don't necessarily know that that's true, but I'm going to go ahead and make that assumption. Tangent is opposite over hypotenuse. We already sort of did this, right? Opposite over hypotenuse. Well, opposite or over hypotenuse, why did I say that? Opposite over adjacent. We kind of made use of this previously. Well, opposite over adjacent is supposed to equal V, or V over 1. This gives me some labeling for my opposite side over here and my adjacent side over here. And I can call my opposite V and my adjacent just 1. And that can actually give me some way to actually solve for my hypotenuse in terms of V. I can use my Pythagorean theorem here. 1 squared plus V squared equals my hypotenuse squared. And the reason I want to even know my hypotenuse is because eventually I'm trying to find the secant of this. Secant is hypotenuse over adjacent. So I'm going to need to know the hypotenuse and put it over the adjacent to actually find the secant of this angle. Well, let's keep going forward with what we were doing. 1 squared is 1 plus V squared. To solve this for the hypotenuse, we're going to go ahead and take the square root of both sides. So we get square root of 1 plus V squared equals the hypotenuse. Square root 1 plus V squared. All right, that's funky, but that's just the length of the hypotenuse in terms of V and 1 using that Pythagorean theorem. So now, remember, our goal here is it's not to find the angle or anything, but it's to find the secant of this angle. So we're looking for the secant of this angle. Secant is equal to hypotenuse over adjacent. So we have the secant of this angle is going to equal the hypotenuse over the adjacent, which is 1 plus V squared, square root of 1 plus V squared over 1. Well, over 1, that doesn't really do anything. I can just turn it into this thing, right? Same thing. So that's what we got. We got the same thing. We were able to demonstrate that the secant of this angle in terms of V is equal to that. Kind of a neat thing, but we totally abstracted the process away from the unit circle, away from numbers and all that. So hopefully that made more sense. There is one on the homework that you can look at to do that. Homework problems, you can find the 3.5 section, the scan is on the Google Classroom page. Here are your homework problems. 58 is that challenge problem that's similar to the one that I just did if you want to challenge yourself. The ones you should really focus on though, right here, lots of examples about that in part 1 and part 2. See you guys later.